Hey guys, welcome back to the resumption of the Zenith porthole projects. Started on these in 2025, took a little bit of a break. Now I am back at it. This particular chassis is from the first Zenith porthole set that I acquired. It came with a dead 16 EP4. I eventually tracked down a replacement. This is the one I last left off working on, I do believe. So, let's get back to it. This is also one that has a odd-looking flyback. The original had been replaced with this guy. Might work okay, but it's not an original Zenith part, and I don't quite like the way it's mounted or wired up. But bigger picture is Zenith porthole flybacks of this type, where they're mounted under the chassis, tend to look absolutely miserable because the coating they use deteriorates badly, which can cause the fine wires to fray or break. So I experimented with removing the coating and putting on a new coating, and I've done a couple of them. This is one of them. So the goal is to put this guy in here and see if this new coating technique worked. And this is a chassis I got it from. So this chassis, trying to remember where I got this. I think this is the one I found it at an estate sale in the garage, and that's where I got the picture tube from. I didn't realize it at the time, but this is, not only did it have the right picture tube, I'm pretty sure this is the identical chassis to this. And I say I think because it doesn't have a clear chassis designator on the back, and it's slightly different, but I think it's close enough we can go off of it. Now, why is that important in this project? Because this was a bit of a mess, especially these power resistors where the coating completely deteriorated and fell away. I can't read the values, and they're open. Now, Sam's didn't do a photo fact for this particular chassis. They just did a one-page schematic, supplementary schematic, and that is it. So I don't have the usual Sam's where they take photos of the actual chassis with a parts locator. So I was having to trace out the wiring and match it up to the schematic. I do have the Zenith service manual. I have the Wallace Teleaid, but they don't show actual images of the chassis with component locator. But now that I have this, which is all original, I can use it. However, right away I noticed something's different. We've got a candome resistor there, we don't here. It's got holes for it, but they don't have any Mars, so I don't think that they were ever used. But the power resistor is here. So maybe it was a production run change, I don't know, but I just checked it out and it's wired up the same as this guy, which gives me more confidence that these two are identical. So I'm going to continue working on this while referring to this guy, and fingers crossed we can get this guy working again. Having this reference chassis just solved another little mystery for me. These guys, we've got two pairs of resistors paralleled up. Looks like 470K and 100K. I had a lot of trouble finding those on the schematic because they don't show two resistors paralleled up. But anyways, by looking at this, you can say, oh, this has two 56K little half watters. Quite a bit different looking. Also, this has a mic cap up here, one hiding down there, and a paper cap here. Whereas over here, we have a paper cap, and then there isn't one down there. So in other words, they look a little bit different, but eventually I figured out what that's part of is this. There's the 256K resistors and the 2200. So in one set, the 2200 is mica, on the other set it's paper. Otherwise the rest is the same, and I believe that all has to do with the phone vision, which was their pay-per-view system. So they're probably not necessary at all for this set to work, because, or are they? So they come up, it picks a signal off from the flyback, and it goes through this network, and it goes to this socket, but it's jumpered. 1, 2, and 3, 4, and then it feeds over into the phase detector. So I'm not sure if you were to unplug that phone vision socket, would the set work right or not. So the deal was, there was a system where you would remove this plug and plug it into a box that would hook up to the telephone system. And you would dial a certain number and pay a certain amount, and you'd have to, I believe, leave the phone connected the whole time you're watching the program, and the phone would pick up a signal that would restore the sync pulses. Without the presence of that signal, the picture would be scrambled. In other words, they intentionally scrambled the broadcast signal, and you needed the aid of that signal coming through your telephone to restore it back to its original functionality. Now, if you're not using any of that stuff, I'm not sure what or how exactly to bypass it or disable it, but they put this shorting plug in there. So anyways, I'll just hook it up the way it's supposed to be, as shown on the schematic and the reference chassis. Also, this set must have been in kind of a rough environment for a while, because the controls are a bit corroded and some of them are frozen, like this guy. And this one moves, but not so great. Now, I could work on that and free it up and perhaps resurrect it, but I could also just take the control from this. And they look different, which also that was a bit curious. This makes me wonder, is one of these an original and one a replacement? Or is it just a production supply change? If I had to guess, I'd say that's a replacement control. But I don't know, because it does look very similar to this guy, which I'm pretty sure is an original. Regardless, I have spare parts if I need to, and that's where I got the flyback from that I recoded that I'm going to transplant into this guy, or attempt to anyways. Alright, that's better. Got this section all rebuilt. Got a good handle on the rest of it. One thing I haven't decided on yet is the electrolytics. Got a dual section here, and they even mounted one up on top. That's obviously a replacement, but yeah, the original is mounted just like that. But then there's these two guys. There are two 4-section twist locks that are really inaccessible. They are, well, there, right underneath the CRT yoke assembly. So, how are we going to replace those? Everybody's got their favorite technique. So, Adaptacap, no. Well, one, Adaptacaps work better on the type that are mounted on phenolic wafers, not twist locks. I would have to remove these and drill holes and all that. I don't think it's worth it. And there are the guys who like to leave them on the chassis and cut them open in place and drill holes and all that. Can't get at them, not unless I dismantle the whole yoke CRT assembly on top, which I don't want to do. And then there's the terminal strip, folks. Okay, where are we going to mount terminal strips? We got 8 caps we need to mount right in here. We've already got terminal strips here, here, here. There's really not a whole lot of room to add them. And then there's, well, hey, just cut off the lugs and tack them in and kind of leave them floating in space, or hot glue them or whatever. Well, that's a possibility too. Another, especially if there's only one wire going to them, but I don't know if that's the case for any of these, but if there was only one wire going to it, you could trace out, hey, where's that wire go? Say it was going to a lug here and mount the cap over here and just take that wire out entirely. But I think that's going to fly, because all these lugs not only have 2 or more wires going to them, they have a bunch of resistors. 1, 2, 3, 4, at least 5 resistors using those as tie points. Boy, this stinks. Like I said, that's why I've been putting these off. Now I've rebuilt the power supply. I can go through and do everything else, get rid of the bumblebees and deal with the flyback, and try powering this with those in place. But I really would like to replace them eventually. So I'll continue on with the rest of the set while I mull that over. Well, let's stay on this topic. I flipped the chassis down and been reviewing how those caps are mounted. But I want to try cutting them open in place. I can remove these tubes, which gives me access from this side. There's 4 screws holding this tower in place. And there's a bunch of wires coming down for the yoke and focus coil. I think there's enough slack. If I remove those 4 screws, I could kind of push this to the side. But then we still have this guy, which is a vertical output transformer, and the tuner, which doesn't give a whole lot of access, especially to that cap. Now, what I'm really leaning towards is disconnect all the wires down below, untwist the twist locks, and finagle the caps out, rebuild them, remount them, retwist the twist locks, hook all the wires back up. More work than I'd like to do, but I think that's really the best way to go about doing it. Alrighty, got the first cap unmounted. Wasn't too tough because of the 4 twist lock tabs, only one of them was soldered. And it wasn't too hard to straighten them all out and pull this out and finagle it out of there after disconnecting all the wires without having to remove any of the stuff on top. Then cut it up with a hacksaw, left a little bit of a lip around it in case I ever wanted to reattach the top. Give me something to work with. And these are the 4 caps that are going to go inside. Now, one thing of note is that 2 of these are 15 microfarad at 475, so I got 500 volt caps for that. And these are all the skinnier variety, so all 4 of these will fit inside that footprint like so. Next up, got some small drill bits, just bought a whole new assortment, so I got some fresh bits to work with. I want to drill 4 small holes, 1 next to each lug for each of the positive, and then I'll do a 5th hole for the common negative. Tie all of these negative leads together and run a bit of bus wire down through that and ground it to the chassis below. This is aluminum, not easy to solder to. I finished rebuilding and remounting both caps, just about done wiring them back up. Reference chassis has been a huge help, which leads me to this. It's an example of the type of stuff I'm running into. So, this power resistor is shot. The coating's gone. Don't know what the value is supposed to be. It's open. So, what do we replace it with? Well, I can look at my reference chassis. It's in better shape, but there's no value because Zenith put part numbers on these, not component values. But even there, the part numbers worn off of this one. Can't read that. Measure it, measures about 13K. Wattage we can guesstimate probably 5 to 10 watts. Okay, I'd like to confirm that on the schematic. Now, Sam's PhotoFact just published a 1-page schematic supplement. Don't have the detailed parts layout or parts identifier. So what can we do? Well, we can look at the Zenith schematic, and I'll save you the drama. I eventually tracked it down to here. 2 8200 ohm resistors listed that go to the same point on one end. Well, here's one of them. So is this the other 8200 ohm? You say I've measured about 13K in this guy. Well, if I trace out the wiring, it sure looks like it's R94, which goes to stuff that basically feeds the flyback. Or, sorry, it picks off the output of the damper tube and gives the boost voltage. I see now. Yeah, okay. Goes to vertical size. Very common deal. They steal some power from the recovered energy from the flyback, give a boost voltage 510 volts, which is higher than the B plus supply, which is 360, I think. So there's some circuits a little bit more voltage. They pull it out of here, and that's where that resistor is going. Okay. No wattage listed. Well, eventually I flipped through this and found it. They do have a parts list, but it's broken up and scattered because they cover a whole bunch of different models in here. But it does say that it's 8200 ohm, 5 watt. So that's what I'm going to put in there. Actually, I'm going to put a 10 watter in there because that's what I have on hand. But that's the kind of stuff that I've been having to struggle with to replace, especially on these power resistors, because they can't read the values on any of them, and they're all bad. They're all open. All right, I think we're ready for a first power up. Finished replacing all the paper caps, all the electrolytics. I repopulated all the tubes. While doing so, I noticed on the parts chassis, I was scavenging stuff I'm using for a reference. Somebody had written in pencil by hand 6AK5 above this tube. But the service info, and what I found in this is a 6BJ6. So I don't know if those are compatible or not, but anyways, I went with what the tube chart says. So, obviously I don't have the full-size metal cone CRT in here. I'm using a little 5AXP4, but the high voltage lead is designed to clip onto that metal bell lip. Right now I just kind of have it gingerly the AXP4. I just want to do a smoke test first off. Can we turn this on? And I don't have a dead short or anything, so power supply here. I'm not going to hook up a speaker just yet. Now these do use an odd power connector. It's not the standard interlock dimensions. Luckily, I scavenged the appropriate type of connector out of here, and because I've been doing a bunch of these sets, so I took one off the back of one of these sets and rigged it up to a line cord. So plug that in. Basically, it's an early type of polarized plug. Go. In a pinch, you could use alligator clips or something like that. Let's see. Set off. I did work the controls up front with some fader lube and a little grease and oil around the shafts, and I got them so they all rotate now. Hopefully, those are all good. Plug it in. Turn it on. Dial into about 117. Put it in current mode. Dim the lights a little bit so you can see the tubes light up, hopefully. And 3, 2, 1, here we go. Oh. The meter did peg over, then it came down. But I heard something kind of popping over here. Let's try that again. Smell any smoke. Could be maybe a stray speck of solder between something somewhere. Tube's lit up though. Let's put this on its side and monitor some voltages when I turn it on next time. Alright, got it on its side now with my meter hooked up to the main supply coming in. Should be about 390 when the set is warmed up. Here we go again. I just set on a couple minutes ago, so it warmed up quickly. So no more snap, crackle, pop, and our B plus is dead on. So, like I said, that may be a loose thing. Another odd thing is where I was hearing that sound was coming from this area, which I didn't do anything here. That's the IF and the detector and AGC and stuff, and it's all ceramic, mica. I did nothing here. So again, it could have been just a stray bit of something or another. Let's take this off, flip it back down. I think my high voltage lead, yeah, it fell off the CRT. I don't think we got any high voltage though, so I don't think we have anything to be concerned about there. I'll grab a fluorescent tube and I'll put it around the horizontal. Oh, there's no fuse. That's probably a good thing. So there, the flyback is fused, and there's no fuse currently in that fuse holder. Let's see, what does it take? Come on, where are you? 1/4 amp, which is really standard for these. So let me dig one up. There we go, some vintage little fuse, 3AG 1/4 amp fuses. Yeah, 1/4 amp. Just do a little check on it first. Remember, this is with the replacement flyback currently installed. Yeah, it's good. Let's pop that guy in. Alright. Let's give this another go. That's not good. We got no signs of life in the high voltage area. Oh yeah, we do. Now we do. Okay, there we go. Boy, it just took a while to come up. You guys can see that. Fluorescent bulb off, fluorescent bulb lit. Which means we should have high voltage. And nothing with CRT, but I don't know if I got the brightness. I don't know which of these myriad of controls here is the brightness. Oh, they're printed. Thank you. Zenith. Brightness. It's this guy. Oh, how about that? There. You guys can see what I did. So as soon as I turn this control up a bit, looky there. Looky there. Woohoo. No, that must be height. One of these guys is contrast. It's probably contrast. Alright, so the fact that when I vary the contrast it's doing crazy stuff means there's some kind of signal coming through. And the fact that when I change the channel clunker, it's reacting, that's also a very good sign. I'm not feeding anything in right now. We can rectify that shortly. Well, I'm happy. I thought this set would give me more trouble. Of course, it's not fully functional by any means yet, but turn on. Hey, look at that. The neon bulb channel indicator lights even lit up. Yeah, these used a neon bulb for a dial lamp. I tried feeding in a signal and I'm not getting anything. I tried it on a bunch of different channels. Wiggled all the tubes. Something's not coming through, so let's take a look inside this tuner because I found a burned open resistor in several of these portholes that I've been working on recently. Let's see if this might also have an issue. Tricky to get this cover off. Screw it out. Kind of lift it up and then back because there's some holes on the back side that go with adjustable coils. There we go. Not the easiest thing to get out of there. Okay, what do we got? It doesn't look too bad. part I'm looking at. So if you watched my series on the Aldrich porthole, it was a burn drop resistor. It might have been that 1K down in there. Looks okay on this, but it just can be deceiving. So I want to see if this fine tuning was. I guess this wasn't. Well, of course, I wasn't getting any reception. I thought it might be something to do with the fine tuning, but yeah, that's all it is. It's just some eccentric circular bits of metal that go in the field of an inductor below it and affect the coupling. I should go through and double check these tubes as well. Make sure I'm not chasing any ghosts, but I'll spot check these resistors. Like there's a 1K, 100 ohm, a 1 meg, a couple 1Ks over here. Let's check all those guys. Kept at it, and I think we have a few things going on here. One, I think we got to clean the tuner. Common problem in these old sets. So I'm rotating the channel selector when I'm kind of in between or approaching channel 6, which is what I'm injecting right now. I start to get something. It's all jumbled and crazy. The more I work this, it seems to be kind of cleaning itself out. Another issue is I do get it to kind of come in. The horizontal hole doesn't have enough range to lock. Alright, so see, there's stripy lines in there. Let me get this better view for you guys. When I adjust the horizontal hold, they get fatter, meaning you're getting closer to the frequency, but never quite gets there. So that's one extreme, that's the other. So this extreme, we're getting close. Now the horizontal frequency adjust, I believe, is this coil that you can't adjust really, rather. From the outside, at least I don't see how it's that guy. And there's a little slug on the end, but they didn't put a hole through the chassis, so... Oh no, it must be that guy. I don't know what that coil's for. I don't seem to be any easy way to adjust it, but this guy, there's a hole through the front there, so... Let me grab a tool. Oh, got one right here. Yeah, we're getting close. Yes. Alright, now we don't have any vertical sync. Let's adjust that. And fantastic. Turn the brightness down a little. Just contrast. Alright. Just fine tuning. The dial string's broken, but I can manually reach over and this knob here. For the full-size metal cone CRT was in there, I would definitely not be doing this. Alright. No. Bench CRT, as I mentioned a million times, they're auto-focusing. The focus coil that's on here messes it up, so I'm not going to worry too much about that. But now that we're at this point, we're going to have some fun. So I was recently in my storage locker going through CRTs looking for something I could use as a substitute in the RCA RR359. I pulled out some interesting CRTs that will work in this set that are different phosphors. So let's have some fun. Also picked up another 5AXP4 a few months ago and I've never tried it out. I want to make sure it's good. And, well, then I have another one that I think will produce an amusing image. So let's shut her down and swap out the CRTs. First up, another 5AXP4, nothing terribly exciting. First up, another 5AXP4 I picked up a while ago. There's a backup for the one I normally use, so that is good. Excellent. I also noticed the set has some issues. It takes a while for the high voltage to come up, for that raster to fill out. So, and sometimes it seems like I have to tap things when I'm using that fluorescent tube. So I'm thinking we might have a good connection, or we might have a weak horizontal output tube. Yeah, so we'll get some stuff to check. Right now I have a little fun with some picture tubes. So that guy is good and working. Now let's try one that's a little bit less conventional. This is one I showed ages ago. I'm talking like at the old apartment. And kind of forgotten about it until I stumbled across it recently. And by the way, the yoke on this is kind of shrunk. It's a little tough to get over the CRT bases. So this guy is, well, one, it's a 7-inch, so it's a little bit bigger. It's a 17 EXP14, a RP14. It's kind of hard to read. But the point is it's P14. Which, of course, is different from the usual P4 you find in these black and white TVs. Let's rig her up and see what it looks like. But it is magnetically deflected, same base pinout and everything. Just got a little clamp on this neck to hold it in place. It's kind of big and heavy. Oh, we got it. And an image is coming in. So this is a kind of a long persistence blue. I think it has a shorter medium persistence white and a long persistence violet, or something like that. If I change the pattern, see there's a ghostly image there for a while. More interesting with live video, I suppose. That's that. Maybe for radar applications or specialty imaging or something like that, but handy for a bench test CRT, especially if you're working on like an RCA 621TS, because this is electrically compatible and physically the same size. Alright, now let's try something a little more unusual. Alright, now we're back to a 5-inch CRT. This is out of a B&K 1077 TV Analyst. It's an ultraviolet phosphor CRT, meant for a flying spot scanner. But, again, magnetically deflected, same base pin out, should produce an image. But it does have an ion trap magnet, so I gotta position that right. Got high voltage. Brighten this up all the way. Oh, there it is. off center. So it's actually about the same persistence as a regular black and white CRT, but obviously it looks a bit different. But in a pinch, again, 5AXP4s are a little hard to come by. You could use one of these. Anything's better than having that big 16-inch metal cone CRT when you're up on the bench troubleshooting one of these. Really curious to see how this footage turns out, because in a viewfinder that looks blue, and on my smartphone camera it looks blue, but in person it's deep violet. Alright, I'm going to leave off here because it's getting late. That was a very successful first power-up. Next time around, we're going to check the audio. We're going to attempt to install this recoded flyback in place of this crummy looking replacement. And I'll swap out this plastic insulating sheet from the other chassis because it's in better shape. And I just noticed I missed one paper cap. It's across the horizontal linearity coil. Probably not going to be much of a factor there because I am puzzled as to why it takes a while for the high voltage to come up and for the screen width to fill out. Typically that means you have a weak horizontal output tube. In this case there's two in parallel, so one or both could be bad. But also something else I didn't do that I usually do, because the horizontal output circuit critical to the operation of the set, and the components can take a lot of abuse during the lifetime of the set. I usually just rebuild the whole thing. In this set I didn't. In particular, I didn't replace all the resistors. There's a 100 ohm and a 150 ohm resistor on each of the horizontal output tubes. I left the original carbon comps in there. I'm sure they have drifted off value, and there's a couple more down in here. It have to do with the feedback circuit, I do believe. I think I should just go ahead and at the very least chuck them, and I should probably just replace them all anyways with more temperature stable components. Alright, all that and more coming up in the next installment. Thanks for watching.